morning everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering at MLR Institute of Technology, Hyderabad. Today I am going to discuss a topic about industrial loads. These are the key points which I am going to discuss today, like introduction to the industrial loads, types of industrial loads, characteristics as well as industrial load categories, power factor and load management, load balancing and diversity, load flow, system design considerations, starting characteristics, its harmonics, and energy efficiency in industrial loads. So first, introduction to the industrial loads. What is an industrial load? Electrical load which is used in industrial applications such as in factories, manufacturing points and processing units is called as industrial loads. These loads includes motors, heaters, lighting systems and other machinery also. So there may be different types of motors, heaters, lighting systems and machineries in a particular industry, and these industries are called as industrial loads. And importance of understanding the industrial loads. Proper load ensures the efficiency, reliability, safety in industrial electrical systems. Means the industrial loads may be more or less or may be stable. That is, they may be variable, they may be fixed based on the time. So the transformers should be connected based on transformers, or the substations should be connected to these industries or factories based on the load capacity of these particular different types of loads like motors, heaters, machineries and lighting systems. What are the different types of industrial loads? Here you can see three types, that is resistive load, inductive load and capacitive load. Resistive load, here you can take an example like heating elements like incandescent lighting. The incandescent bulbs will be using this resistive load. The characteristics are constant power consumption, they are purely resistive. The second one is inductive loads. Examples are motors and transformers as well as the solenoids. The motors, transformers and solenoids will be using the inductive loads. The characteristics means they require reactive power. Here they require only active power, that is DC power. Here they require reactive power and exhibits phase shift between the current as well as the voltage. The third one is capacitive load. Example is capacitor banks which are used for the power factor correction. In order to improve the overall system efficiency, the power factor should be maintained properly or it should be corrected. In order to correct the power factor, the capacitor banks are being used. So these are the different types of loads, resistive, inductive as well as capacitive. Next one is characteristics of industrial loads. What are the different characteristics? Like first one is load variability. That means constant loads as well as variable loads. The loads may be constant or variable. Constant means continuous power consumption. Examples, lighting and control circuits. For lighting system as well as control systems, the load is continuous. The load consumption is continuous based on the time. Variable loads means fluctuate, depends upon the process of production cycles. Example, the pumps and compressors. The pumps and compressors, the load may be varying. It is not fixed. So the load variability will be there. Constant load as well as variable loads will be there in the industries. The second one is load nature. What is the nature of the load? It may be a linear load or a non-linear load. Linear load means which obeys the linearity property between the voltage as well as current. Linearity property between the voltage and the current. The loads which obey the linearity property are called as a linear loads. Examples are resistive heating. Resistive heating is nothing but this incandescent lamp lighting system. The second one is non-linear loads. The current and voltage waveforms are not sinusoidal. Example, welding machines and rectifiers. In welding machines and rectifiers, the VI characteristics are not linear. So, these are called as a non-linear loads. Next one is power factor. Power factor, you have leading power factor as well as lagging power factor. The inductive loads, example, motors. The inductive loads, that is motors, can cause a lag between voltage and current. Can cause a lag between voltage and current. That means the voltage waveforms as well as current waveforms will not match each other. Next one is leading power factor. Capacitive loads. Example, the capacitor banks. As I said previously, in order to correct the power factor, we will be using the capacitor banks, and these capacitor banks will cause a lead. To the voltage. So, these are the different types of loads. Next one is industrial load categories. What are the different categories? The first category is motors and drives. That means AC motors, DC motors, variable frequency drivers, VFD. Okay. So, AC, DC, variable frequency motors are the different types of motors which are being used, and their consideration is like the size, the speed, the torque, as well as the starting current and the power factor. All these things should be considered. So, based on the size, speed, torque and starting current and the power factor and the load which is connected to this particular motor depends upon the based on that we will select the different types of motor, that is AC or else the DC motor. Next one is heaters. What are the heaters? That means electric ovens, furnaces as well as resistance heaters these three comes under the category of heaters. Next, their consideration is temperature control, load balance and efficiency. Temperature control, load balance and the efficiency. The third one is lighting. There are different type of lighting systems, that is the fluorescent lighting or high intensity discharge. So, based on the room, based on the application, we can consider different types, that is fluorescent or high intensity discharge. Next one is pumping and compressors. Pumping and compressors. The centrifugal pumps as well as the reciprocating compressors are being used as an industrial loads, which have load cycle, startup conditions and energy consumption. So, based on the load cycles, based on the startup conditions as well as energy consumption, the centrifugal pumps as well as the reciprocating pumps are being selected. The next one is welding and other industrial equipment. The welding and other industrial equipment. There are different types like arc welders and electric furnaces like kilns. So, all these three comes under the category of welding and other electrical equipment, where high power demand or non-linear, they have non-linear characteristics and they will be using the high power. Next one is power factor as well as the load management. Understanding the power factor. Power factor PF. Power factor PF is nothing but real power to the apparent power. This is measured in kilowatts. This is measured in kVA. Okay. So you will be having active power, reactive power, real power, apparent power. So the power factor is the ratio of real power to the apparent power. Real power you will measure in kilowatts and apparent power you will be measured in kilovolt ampere. So low power factor. Low power factor due to inductive loads. When more number of inductive loads are being connected, the power factor will reduce. So it will be low power factor. It increases the need for reactive power. It increases the need for the reactive power, which impacts the system efficiency. This impacts the system efficiency. Means for low power factor, we need more amount of reactive, which increases more amount of reactive power. Next one is improving power factor. First, we need to understand what is power factor. After that, we need to improve the power factor. In order to improve the power factor, we will be using these capacitor banks. We will be using the capacitor banks used to offset the inductive reactance. In order to improve the inductive reactance, we will be connecting the capacitor banks to improve the power factor. So, synchronous condensers. Synchronous condensers means rotating machines that provide the reactive power. Synchronous condensers are nothing but the rotating machines that provide the reactive power. Impact of low power factor. What is the impact of low power factor? Increased losses. That means when the power factor is low, the losses will increase in transmission as well as in the distribution. The losses will increase in transmission as well as in the distribution. And overall sizing of generator as well as the transformer. The overall size of the generator as well as the transformer also differs based on impact on the low power factor. Next one is higher electricity cost. The cost of the electricity also increases when the power factor is low. So, when the power factor reduces, it increases the losses, it increases the electrical cost, and it increases the overall size of the generator as well as the transformers also. Next one is load balancing and diversity. Load balancing, the process of distributing loads. Process of distributing loads evenly across all the phases to prevent the overloading on any single phase is called the load balancing. That means there are three different lines, three phases. For a three-phase line, R, Y and B. Three-phase line will be there, and for all the three phases, equal or even load should be connected. All these three phases should be connected to equal amount of loads. This is which is nothing but the load balancing. And if any overloading occurs, the disturbance as well as the harmonics will occur. Next one is diversity factor. Diversity factor means a measure of ratio between sum of individual maximum demands and the maximum demand of entire system. Okay, sum of the individual max demands to the maximum demand of the overall system. Like if the overall system is there, inside this you will be having different components, and each will be having a maximum demand. Each component will be having a maximum demand. So, sum of the maximum demand of each component to the overall maximum demand is nothing but your diversity factor. So which helps the optimizing transformer and generator sizing, which helps in selecting the transformer as well as the size of a generator. Example is like a factory with multiple machines operating at different times. The diversity factor helps in determining the peak load and avoiding the oversizing. It helps us to determine the peak load and avoiding the oversizing. Next one is load flow and system design considerations. Load flow analysis. It is used to understand the voltage profiles as well as power distribution as well as losses in the system. Load flow analysis is used for determining the voltage profiles, the power distribution as well as losses in a particular system. It helps in determining the required capacity of generators, transformers and the distribution systems. Required capacity of generators, transformers as well as the distribution systems. What are the different considerations for system design? What factors that we should consider are like the voltage levels, its safety margins as well as the backup power. The power backup also should be considered. So we should ensure the voltage drop within the accepted limits, whether it is within limits or not. Next, account for future load growth. So in future the load may increase. So considering the future load growth also, we should design the system as well as power backup. That is, we should ensure the adequate power from the standby generators during the power failures before itself. The next one is starting characteristics of an industrial loads. What are the starting characteristics? First one is inrush current. Inrush current means motors and other equipment draw larger currents at startup. Means during the starting time, for starting of a motor, it will use or it will draw more amount of current and maybe several times normal running condition also. During the starting period, during the starting of a motor, it will consume more amount of current, and during running conditions also in some cases it may draw more amount of current. So next one, soft starters and VFD. Devices like soft starters as well as variable frequency drives. VFD means variable frequency drives. Helps us to reduce the currents as well as control motor startup. In order to control the motor startup as well as the current drawn from the motor startup, the soft starters and VFDs are being used. Impact on the power system. What is the impact? This high inrush currents can cause a voltage dips or harmonics in the system, affecting sensitive equipment. Means for a transformer, as I said, for a transformer, if the voltage increases, current reduces, and if the current increases, the voltage reduces. So when the starting current is increasing, the voltage may reduce, and this reduce in the voltage is nothing but voltage dips. This voltage dips will cause harmonics into the system, which will affect the overall system efficiency. So these are the different things. Next one is harmonics in industrial loads. What are the harmonics in the industrial loads? Here there are nonlinear loads and harmonics. That is, nonlinear loads such as rectifiers, computers, welders generate harmonic currents. As I previously said, as the current drawn differs, the voltage changes. When the voltage changes, the harmonics may occur which will disturb the overall efficiency of the system. Next one is effects of the harmonics. What are the effects of the harmonics? The increased losses in transformers as well as conductors. As the harmonics increases, the losses in the transformer as well as the conductors increases. And overheating of electrical equipment. The equipment may get overheated and it may get damaged. The third effect is disturbances in communication system. Disturbances in communication system. So the harmonics can cause disturbances in communication system also. The next one is mitigation technique. Mitigation technique means filters. Active or passive filters are used to remove or reduce the harmonic currents. Mitigation means reducing or for improving the efficiency. We will be using the different types of filters, active and passive filters to remove the harmonics from the currents. Next one is K-rated transformer, means designed to handle harmonic load currents. It is designed to handle the harmonic load currents. Energy efficiency in industrial loads. Energy efficiency measures like motor efficiency, lighting efficiency and process optimization. Using energy efficient motors and drives. We should use energy efficient motors and drives, and we should switch to the LED instead of incandescent lamp in order to improve the energy efficient lighting and process optimization. That means using intelligent controls for heating, cooling as well as mechanical processes. So benefits of energy efficiency. What are the benefits are like reduced operating costs. The operation cost reduces when the energy efficiency increases. Next, lower environmental impact. The impact on the environment reduces, and compliance with regulations and standards. That we follow all types of regulations as well as standards when the energy efficiency is being improved. So all these are the benefits of energy efficiency. Industrial load analysis. What is the analysis which is being done? Identify the loads, calculate the power consumption, the power factor as well as the harmonic distortion. The third step is to implement solutions like power factor correction, that is by using the capacitor banks, harmonic filtering, that is by using the active and passive filters, and load balancing, that is trying to maintain a constant load instead of variable load. So all these things are the to analyze the various equipments, different steps. Next one, key points. What are the key points are like? Industrial loads vary greatly depending on the type of the equipment used, based on the type. Next one is proper load management. Proper load management. That means instead of variable load, if we try to maintain a constant load, the overall system efficiency will improve, will reduce the cost and ensure the reliability on that particular system. Next one is power factor correction, the load balancing as well as harmonic management are critical in the industrial systems. So all these key points we have seen in the lecture. In next lecture, I would like to discuss about motors and starting of the motors. Thank you.